We're solving problem 6.1 from Sadiku, Fundamental of Electrical and Electronic Engineering book. So the problem says if the voltage across a 7.5 Faraday capacitors is 2t e to the power minus 3t volt, then find the voltage and power. Okay, so before heading into the problem, let's learn basics briefly. Here we know for capacitors Q equals to CV, right? Q equals to CV, where Q equals to charge, C equals to capacitance, and V equals to voltage across the capacitors, right? Okay, let's differentiate both the sides. So ultimately it will be like dq by dt. As we know, capacitance is constant with respect to time, so it will be out of the differentiation, so it will be C dv by dt, right? Okay, dq by dt equals to C dv by dt. Now we can call dq by dt as current. We know that from our SSC basics, right? Okay, so I equals to C dv dt. So that's the equation for our current. And if we want to calculate the voltage, we can simply integrate the both sides. Let's just simplify this. It will be like dv equals to 1 by C I dt. Let's integrate both the sides. It will be dv equals to 1 by C. As again 1 by C is constant, it will be out of the integration. So dv equals to 1 by C integration of I dt. So the limiting value will be 0 to V, and it will be T naught to T. So if we wanna calculate the voltage in a particular time, it will be Vt equals to 1 by C integration of T naught to T I dt plus V naught, because we are calculating the voltage in a particular time. So we have to add the value of voltage at 0 or initial voltage, whatever you want to call it. So for this problem, let's just jump into that. So here the current I equals to C dv by dt, right? Okay, I equals to C dv by dt. So I equals to C dv by dt, I equals to C, the capacitance value equals to 7.5 gun d by dt of, what is the value of V? 2t e to the power minus 3t, right? Okay, so let's just differentiate the both sides. 7.5 gun 2 will be constant, it will be outside of the differentiation. Then simply use uv or whatever you wanna use here. So it will be t minus 3 e to the power minus 3t plus e to the power minus 3t into 1. So the ultimate value will be 15 minus 3 e to minus 3 t e to the power minus 3t plus e to the power minus 3t for current. And let's just calculate voltage also. I don't think we need voltage in this, so let's just calculate the power. For power we know P equals to VI, right? P equals to VI. Here V equals to what? V equals to 2t e to the power minus 3t. So 2t e to the power minus 3t into 15 minus 3t e to the power minus 3t plus 3 e to the power minus 3t, right? Okay, so let's just sum that all the things. 330t e to the power minus 3t into minus 3t e to the power minus 3t plus e to the power minus 3t. What it will be the answer? Let me just check this real quick. 30t e to the power minus 3t minus 3t et. It's okay. So it is the answer. It is the answer, and it is the answer. Okay. Achha. Now let's move forward to problem number 6.2. The problem says 50 microfarad capacitor has energy Wt equals to 10 cos square 377 t joule. Determine the current through the capacitor. Okay, from the integral part we know W equals to half CV square. If you guys need the proof, let's just comment in the video. So W equals to half CV square. We may write this as W equals to, or V equals to V square equals to 2W by C, right? Or V equals to 2W by C root over. Okay, we can write this out. So it will be 2 into 10 cos square 377 t divided by C. What is C? C is capacitance 50 into 10 by 6 for microcoulomb. It will be the root value. Okay, so the answer will be V equals to, let me just calculate that, 20 cos square 377t 50 into 10 inverse 6. So the value will be 632.5 cos 377t. Okay, it will be the value of my voltage equation. Now they wanted us to calculate the current. Again we can use the voltage equation from there. So the equation will be Vt equals to, or okay, they wanted the current, so current I equals to C dV by dt. So I equals to C dV by dt, right? So here C is 15 to 10 by 6 and the dV by dt of this value, right, this value. So it will be 632.5 cos 377t. Let's just differentiate the both sides. So it will be 50 into 10 inverse 6 into 632.5 into minus sign 377t into 377, right? The differentiation of cos x equals to minus sin x, right? Okay, so let's just calculate this all together. It will be okay, so it will be minus 11.923 sine 377 t ampere. This is the answer. So this is the basically answer of the number 6.1 and this is the answer of the 6.2. I hope you enjoyed the video. Thank you.